Hello students, in our previous class, that is in our previous video, we discussed about the parallel combination of two cells. First one is the series combination of these cells and second one is the parallel combination of these cells. In case of the series combination of these cells, what is the effective EMF? In case of the helping manner, E equivalent is equal to E1 plus E2 plus E3 and so on En. In case opposing manner, E equivalent is equal in case of the two cells. E1 difference E2. So at the same time, in case of this is in case of the series combination. In case of the parallel combination of these cells, E equivalent is equal to E1 R2 plus E2 R1 by R1 plus R2. This is the equivalent EMF when two cells are connected in the parallel combination. That is how that is. Positive terminals are connected at one point and negative terminals of these cells are connected at another point. In this situation, here EMF is the E1 internal resistance R1, E2 and internal resistance is R2. So in case of positive is connected to the negative like this, in this situation equivalent EMF is equal to E1 R2 difference E2 R1 by R1 plus R2. Already we discussed this one. Okay. So in case next one, when two cells, not only two cells, in case that is the wrong connection. In case of this series combination, so in case if we connected these some wrong connection, that is I think with by mistake negative terminal of the battery is connected to the negative terminal of the another battery, not the positive one. Negative terminal like this. Observe. Here, this is the EMF of the cell having the EMF E1 and internal resistance R1. Such type of the N cells are there. So in the situation, if all are connected in the helping manner, here EMF E equivalent is equal to N into E. E equivalent is equal to, that is the equivalent EMF of the series combination of the N cells. That is E equivalent is equal to Ne. But in case by mistake in N cells, M cells are connected wrongly. Then what is the equivalent EMF? E is the EMF of the cell. Such type of the N cells are there. In that one, M cells are connected wrongly. Then what is the equivalent EMF? So here equivalent EMF in this situation, E equivalent is equal to N minus 2M into E. This is the equivalent EMF. Yes, okay. I will explain. Actually here 3 cells are there. N is equal to 3 cells. In that one cell is connected wrongly. Then equivalent EMF is equal to, that is the 3 minus 2 into 1 whole into E. That is equal to 3 minus 2 is equal to E. That is 3 minus 2 that is equal to 1. Therefore equivalent EMF is equal to E. So we are proving this one by using the Kirchhoff laws also. Okay. So when we are taking the three cells, in that one cell is connected wrongly, then equivalent EMF is equal to how much? Then equivalent EMF is equal to how much? So this is the first cell having internal resistance R and EMF is E. Second cell, this is also helping manner. Third one is the by mistake connected wrongly. Total this is connected to the external resistor. External resistor. So then what about the equivalent EMF? What about the equivalent EMF? So apply here, this is I is the current passing through the external resistor. Here internal resistance is present. Here internal resistances are present. So when we are applying the Kirchhoff voltage law for this loop, E positive terminal of the battery, E minus potential drop across the external resistor, that is the IR. Next, here internal resistance is present, that is the potential drop across the internal resistance, that is the minus IR drop, potential drop. Next one here, this one, in this cell also potential is dropped, therefore EMF is equal to, that is the minus E. Next, from the negative to the positive, actually here internal resistance is present, that is minus IR, potential drop across this internal resistance minus IR. Next one, the current is, next one, we are moving from the negative terminal to the positive terminal, means EMF is increases, potential gain, that is nothing but place E, yes, place E. Here is also one internal resistance is there, that is nothing but the potential drop across that internal resistance is equal to minus R. Therefore, here equivalent EMF is equal. Right now, these two are cancelled. EMF E minus, this is the I into capital R plus small r plus small r plus small r is equal to G. So therefore, E is equal to I into R plus 3R. Therefore, current I is equal to, this is the E by capital R plus 3 into R. Here equivalent EMF is equal to how much? When we are taking three identical cells, in the situation one is connected wrongly, one cell is connected wrongly, then equivalent EMF is equal to this one, E. Already we know what is the expression in the situation. E equivalent is equal to N minus 2M into E. N minus 2M into E. This is the equivalent EMF when cells are connected wrongly in case of the series combination. This is the expression for the equivalent EMF. In case equivalent internal resistance is equal to how much? That is NR only. That is NR only, no doubt. But EMF is changes. EMF is changes. Okay. Next one, mixed combination of cells. Next one, mixed combination of cells. Mixed combination of cells. Here, first of all, we are considering the N cells. Each of the EMF E and internal resistance is R. N cells, each of the EMF E and internal resistance is R. Internal resistance is R. So then what happened? Here, observe. Here, N cells, those are connected in the series combination. This is the internal resistance. So all are connected here in the helping manner. So this one is again positive and negative internal resistance. So like that, N cells are connected here. N cells, those are connected in the series combination. N cells are connected in the series combination. Each of the EMF E and internal resistance is R. Each of the EMF E and internal resistance are, how many cells are there? N cells. Such type of the rows, M rows are there. M rows are present. Here, M rows are present. M rows are present. Here all are connected in the parallel combination. So all are connected in the parallel combination. Here m rows are there. In each row how many cells are there? N cells are there. N cells are there. Right now, total this combination, mixed combination is connected to the external resistor capital R. That is connected to the external resistor capital R. Capital R. So all are the identical cells. Here EMF is the E, internal resistance is R. No need to represent here. No need to represent. Yes, right now. What is the equivalent EMF for this mixed combination? What is the equivalent EMF for this mixed combination? Try to observe. First of all, when two cells, two identical cells, E comma E and internal resistances R comma R, those are connected in the parallel combination. Those are connected in the parallel combination. E equivalent is equal to E1 R2 plus E2 R1 by R1 plus R2. So from this expression, E equivalent is equal to E into R into E into R by R plus R, that is the 2R. Therefore, E equivalent is equal to E only. This is the 2E R by 2R. 2R cancel. Equivalent EMF is equal to E. When N identical cells, those are connected. All are having the equal EMF. Equal EMF. All are connected in the parallel combination. Then equivalent EMF is equal to the EMF of the individual cell only. EMF of the individual cell. Yes. For that, here observe. So when cells are connected in the series combination, equivalent EMF is equal to, this is the equivalent EMF, that is nothing but the NE, and equivalent internal resistance is the NR. N cells are connected in the parallel combination. Therefore, E equivalent in case of the series combination is not parallel combination, series combination. N cells are connected in the series combination. Then E equivalent is equal to E1 plus E2 plus E3 plus and so on En. All are the identical cells. E plus E and so on E. That is equal to N times, that is the Ne. Ne is the equivalent equivalent EMF when cells are connected in the series combination. So here this is the equivalent EMF for this series combination, and this is the equivalent internal resistance for the first row. For the first row. How many such rows are there? M rows are there. Therefore, here second row, this one is the second row. All of them have the same EMF, that is the Ne and Nr. This is connected to the external resistor capital R. This is the capital R. Here Ne and internal resistance is Nr. Internal resistance is Nr. So observe, here all these cells are connected in the parallel combination. All these cells have the equal EMF. Then what about the equivalent EMF in this situation? That is nothing but E equivalent for the mixed combination, that is nothing but Ne only. When two cells are connected in the parallel combination, two identical cells are connected in the parallel combination, then equivalent EMF is equal to how much? That is nothing but EMF of the individual cell. Here is also same. Ne is the equivalent EMF, maybe this is the Ne is the EMF of particular cell. So how many such cells are there? M cells are there. All are connected in the parallel combination. Then equivalent EMF is equal to Ne. What about the equivalent internal resistance? R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on. But here all are the identical, that is the 1 by R, how many times? M times are there. M times, how many cells? That is how many rows we have, that is the M rows are there. Therefore, equivalent 1 by R equivalent is equal to M by NR. M by NR. Therefore, from this one, R equivalent is equal to N R by M. R equivalent is equal to N R by M. Here, R equivalent is equal to, that is the N R by M. Therefore, total resistance in that circuit, this N R by M is in series with the capital R. Therefore, capital R plus N R by M. This is the total resistance. That is the total resistance. Observe. So, what are the factors we get right now? Here, what is the equivalent EMF when cells are connected in the mixed combination? When cells are connected in the mixed combination, E equivalent is equal to, that is nothing but the NE. R equivalent is equal to NR by M. NR by M. R total is equal to NR by M plus a capital R. NR by M plus capital R. So then what is the current passing through the external resistor? What is the current passing through this external resistor? I would like to consider that I is the current passing through that external resistor. Therefore, I is equal to E equivalent by R total. E equivalent by R total. Therefore, I is equal to NE by R total is equal to, that is the NR by M plus a capital R. NR by M plus a capital R. This is the current passing through that external resistor. This is the current passing through the external resistor. When this current becomes maximum, when this current becomes maximum, when this denominator term becomes minimum, then current becomes maximum. Observe here, this is I is equal to M into N into E by NR plus M into capital R. M into capital R. When this term, denominator term becomes minimum, then current becomes maximum. Current becomes maximum. When that one is possible, when current, that is the denominator term becomes minimum, then current becomes maximum. So that is, if I becomes maximum, when NR plus M into capital R is equal to 0. This denominator term becomes 0, then the total current becomes maximum. I becomes maximum. So here observe this one. From this one, here N into R plus M into capital R, N into R plus M into capital R, minus 2 into square root of MR into square root of NR plus 2 into square root of MR into square root of NR is equal to 0. Added and subtracted the same term. That value does not changes. That value does not change. Right now, I am writing this one like this. Observe. Square root of M into R minus square root of N into small r whole square plus 2 into square root of MR into square root of NR is equal to 0. Is equal to 0. So we are not changing the term. We are added and subtracted this some extra term. So from this one we write it. This one we write it square root of MR minus square root of NR whole square. A minus B whole square formula. Expanding that one. MR plus NR minus 2 into MR into NR. So here observe this one, here observe this one. This one never be equal to 0. This one never be equal to 0. That one does not have the chance to become 0. So observe here, in case if MR is equal to NR, this term becomes 0. But this one not equal to 0. Here there is a chance. Here that one is a chance. This term becomes 0, not this term. Not the second term. First term becomes 0, they have the chances. They have the chance. So for that, yes, square root of MR minus square root of NR whole square is equal to 0. That will never be equal to 0. So when this one is equal to 0, square root of mr minus the square root of nr is equal to 0. Therefore mr is equal to nr. Therefore r is equal to nr by n. R is equal to nr by n. Observe here, when the external resistance is equal to when R means R is nothing but the external resistance. This external resistance is equal to the equivalent equivalent internal resistance of the mixed combination. Equivalent internal resistance of the mixed combination. In that situation, the current becomes maximum. The current becomes maximum. Therefore, maximum current. Therefore, maximum current is equal to m into n into e by, this is the nr plus m into capital R means this is nothing but the nr by n. M cancel. Therefore, I max is equal to mne by 2 into n into r. N cancel. Therefore, maximum current is equal to me by 2r. This is the maximum current when n cells connected in series. Such type of the m rows are there. That is nothing but the mixed combination. In case of the mixed combination, maximum value of the current is equal to this one. Equivalent EMF is equal to Ne, equivalent internal resistance is equal to Nr by M. This one is the total resistance in that circuit. Total resistance in that circuit. Okay? Right. So next topic, in the next topic, we are discussing about the potentiometer. Okay? We will discuss that one in the next video. Okay? Bye all of you.